Today, we will talk about the basics about acoustics, and then we will see why it's a next big challenge in automotive, aerospace, and as well as other home appliance manufacturers. Before we start, I think most of you are already familiar about the term acoustics. Acoustics is a branch of physics, basically, and it deals about sound. And acoustics is nowadays an important aspect, and also it's a big marketing aspect, because whenever you see some advertisements about premium cars or premium devices like microphones, etc., they talk about acoustics. And the acoustic comfort has become very important nowadays. And this is why we are here today. And the typical applications of building acoustics, like in a homes, houses, especially when your house is located within a city and where you have a lot of traffic, it is very important that your house is perfectly insulated. This can be done by different types of modern windows, for example, or some acoustic materials like styrofoam. There are several methods how you can insulate your house against the noise coming from outside. And even in the cinemas and the theaters, you see they're acoustically perfect. You feel a perfect silence whenever you enter into the cinema. This is because the modern theaters and the cinemas are equipped with digital sound systems, and it is very important that the sound stays within the theater. And even the noise coming from the outside should be cancelled. So the noise cancellation is also very important. And the next application is vehicle acoustics. The vehicle could be an automobile or even an aircraft. And in automotive, customers are nowadays complaining about the road noise and the powertrain noise. It's this affecting the comfort of the passengers. So the people have started to complain about this, and this is why the engineers are here to solve this problem. And it has become a big challenge in automotive industry. And in aerospace, as you know, aircrafts are really loud, and with the more and more engines like Airbus 380, the noise is getting only worse. So what does that mean? The aircraft cabin, that means the interior, should be perfectly insulated to avoid the noise from these big engines to enter inside the cabin, right? And then we have device acoustics. This is something which all of us are familiar about now. This is about headphones, speakers. The headphones, each and every headphone, what we are buying today, the premium headphones, are equipped with noise cancellation. And without noise cancellation, you don't see any premium headphone. And even the speakers, the sound should be clear and it's perfectly audible. This is one of the main aspects of speakers. And also the home appliances like washing machines or vacuum cleaners, dishwashers, all the companies are trying to make their devices as less noisy as possible. And they have their own limits. I think it's around 65 decibels. And they are trying to bring it much below this level. So it's a kind of, there is a race going on in the home appliance manufacturers to make their devices as silent as possible. Okay, acoustics is fine, but what is acoustics anyway? As I mentioned, it's about sound, and what is sound is a fluctuation of pressure in a medium. This is something like when you imagine a clear and quiet pond or a lake of water, you throw a stone into it, and you see the ripples and waves traveling everywhere. Suddenly, sound is similar. So you have a sound source. It could be a person speaking or a vehicle or a bird chirping. You see the waves, the pressure waves start to travel in all directions from the sound source. And you got some receivers, which could be a device like a microphone, or could be a natural device like our ears. They capture this sound pressure difference. This sound pressure difference is sound. So the medium is not only air, but it can also be water, or even it could be a solid like metal or wood. And sound travels at different speeds in different media. So to give you a quick idea, sound travels much faster in water than in air. And this is one of the important aspects when you are designing submarines or something like ships, for example. And it is important to make sure that the unit for sound is decibels. So we measure sound in decibels. Okay, then the next question. So we are always speaking about noise cancellation, traffic noise. So the most popular thing about acoustics you hear about is noise. So what is noise? Noise is sound. Noise is no different than sound. But why do we call it noise? Sound, for example, when you are listening to your favorite song, it is not noise. This is the sound which you like to hear. And even the bird chirping, something you like to hear. But anything like a traffic noise, for example, or a big machine working next to you, this is noise because you don't want to listen to this noise. This is something which annoys you. So now the noise is something, it's a sound, but it is something which we don't want to hear. And the scientists have prepared a small table like this. The scientists have created, acoustic scientists, they have created a small table like this one, see on your screen. So they have created a table with different levels of noise in decibels, and they gave it a scale, and you can check the noise levels even in your mobile phones. There are applications to check the noise levels in your phone so that you can be aware of the noise around you in the environment you are in. And it is important to know that anything above the orange zone of the scale could be really dangerous for your ears. And this can cause immediate hearing loss. So just to keep it simple, that about 30 to 60 decibels is something which you hear every day, like a soft music or someone whispering in the background, or average home noise, and some normal conversations in your office or at home. They all fall within this range, 30 to 60 decibels. But above 60 decibels, you got office noise till heavy traffic. But this is the absolute limit. So once you are at this limit of about 80 decibels, this is already dangerous for your ears. So if you are exposed to 80 decibels or 90 decibels continuously, this will cause hearing loss. And anything above 120 decibels can cause immediate, so spontaneous hearing loss. And something about 120 decibels, you don't hear that often. This is something which you hear when you are in a big cricket match. When someone hits a six, then you have a noise that can be really dangerous if you're exposed to that noise for long periods. The pleasant sound is something which is below 30 decibels, or at least between 30 to 40 decibels. So everything going beyond 40 decibels, everything beyond 40 decibels is noise. Okay, so it is fine. So we have seen a scale there. It goes until 140 decibels. And you might be asking yourself how loud sound can be. To give you a short example, the loudest sound ever recorded on Earth was in 1980s. It was caused by a volcanic eruption in a place called Krakatoa in Indonesia. It was so loud, it was heard by people living 3,000 miles away in Australia. And it was around 183 decibels. So the people living near this volcano, they lost their, it caused severe damage to their ears, and many people were immediately deaf. So again, any noise above 120 decibels can cause immediate hearing loss. And the maximum level of the loudest sound possible in Earth's atmosphere is 194 decibels. So what does it mean? That's why I'm stressing it's in Earth's atmosphere. So if you talk about water or another planet where the atmospheric pressure is a bit higher, it can go beyond 194 decibels. Now you understand why acoustics is getting more and more, becoming more and more important. So you could ask yourself again, why acoustics? Yeah, because noise is one of the key problems nowadays in automotive and aerospace, because of customers started to complain about acoustic comfort in their vehicles. So, but for today's webinar, it will be more generic, but the focus will be mostly on automotive. And to give you a quick idea, as you saw the scale about the acoustic noise, the normal passenger vehicles, the noise is around 68 decibels. And the SUVs and vans, about 70 decibels. And the lorries and trucks, they are beyond 78 decibels. Yeah, acoustics is important, not only because comfort level of the passengers, of the customers, but also we have a lot of norms in each and every country. So all the countries are tending towards stricter norms, especially in Europe, very strict norms coming from the vehicles. And again, acoustic comfort will also be a very important marketing aspect. We are familiar with Tesla. They have marketed their automobiles to be one of the quietest among the batch. So every electric vehicle manufacturer nowadays is trying to project their vehicle to be acoustically superior compared to other cars. So it's also a big marketing aspect. So why am I talking about electric cars suddenly? You can see it now, because with the conventional automobiles, when I mean conventional automobiles, the IC engine automobiles with the internal combustion, we have engines, and the engines are really loud. This is something we call powertrain noise, and it has dominated the other noises until now. And this you'll see in the next slide. Here you could see the actual contribution of different types of noises in an automobile. In a conventional automobile, so with combustion engines, until now, the powertrain noise contributed up to about 50% in an automobile. So the powertrain noise. So 30% is road noise, and wind noise about 10%, and the other ancillary noise about 10% again. And now we have a boom of electric vehicles everywhere. And what are electric vehicles? They don't have an engine with internal combustion. So we have electric motors integrated into the vehicles. And the electric motors are really, really quiet compared to conventional engines. And this is what you could see here on the right, this picture. You see the powertrain noise here contributes only 10%. This is because of the electric motors, right? And you could see the big contribution, surprisingly, comes from the road noise and wind noise. And the wind noise, in case of combustion engines, was just 10%. So what does that mean? With the arrival of electric vehicles, we have a new level of challenge, a different challenge. So we have to control the noises which were not dominant until now, and which have suddenly become dominant and are a big challenge, especially when you're driving your vehicle over 120 kilometers per hour. You have the wind noise, which is really noisy, can even dominate the road noise after 160 kilometers per hour. So these are new challenges. These are not known until now because of the combustion engines. Now suddenly we have electric vehicles, and we have to somehow solve these challenges and face these challenges. Okay, acoustics are important. This is clear. And to just to give you a brief idea about how the acoustic testing as well as analysis is done, we have two different terms which are very important. The acoustic testing or analysis can be done either in time domain or in frequency domain. I'm not going to talk much about these topics today because it's quite technical, but just to give you a quick idea, a time domain is the data recorded over time. And what does that mean? You have your car placed in an acoustic chamber, you switch on your microphones, you start the sound source, and you wait for a few seconds to few minutes or sometimes hours. So this is time. And you measure the amplitude of the noise within this time frame. That is time domain. And then you see peaks in the graph, within the measurement you made in time domain, and these peaks correspond to certain frequencies. So you just pick this frequency range, and you then do some kind of analysis or testing within this frequency range, and you check for the amplitude or the peaks again within this frequency range, and this is frequency domain. And in general, the testing is mostly done in time domain, and the analysis, the acoustic analysis is done in frequency domain. I'm not, as I said, I'm not going to go deep into the topic. It's quite technical, but I think you got an idea what I mean. So again, the testing, to keep things simple, what you see here is our sample. It's kind of, it can be rubber or any material, wood or and composite, for example, or plastic somehow. But what we do is we have a sound source and we emit sound to a sound source and let the sound pass through this barrier of our sample. And what can happen? It can be there are only three possibilities. Either the sound will be absorbed by the material, some part of it will be reflected back, and some part will be transmitted through the material. Okay, it's quite interesting, but this term, this difference between the sound intensity on the emission side and the sound intensity on the transmission side is called sound transmission loss. And this is a very important term in acoustics. It looks quite simple, and it's also quite simple, but once you understand it, only if you understand it. So what does it mean? Sound transmission loss is the difference in intensity between the emission side and the reception side, right? So the sound transmission loss should be as small or as minimum as possible so that we can call the material to be superior. So the efficiency of the material is good. This is what I mentioned here too. The material is acoustically good if it absorbs maximum sound and transmits less. So this is the maximum sound, the minimum sound transmission loss. I'm sorry, the sound transmission loss should be high. Okay, so how will the sound transmission loss measured in reality? This is a typical setup of sound transmission loss measurement. This is called an impedance tube. I think you already get an idea. We have a speaker here, which is our sound source, and we have our sample, and we have got some microphones. So sound is passed or emitted onto the specimen, and we got some sound being reflected, and some sound is absorbed, and we have different microphones to measure sound at different points. This is how we measure the sound transmission loss inside a tube. And of course, the impedance tube measurement is only for a small part. If we have to measure the acoustic performance of the whole vehicle, then you would need an acoustic chamber. It's a big acoustic room. It's called a semi-anechoic chamber. What you basically do is you put your vehicle in this acoustic room, and typically the acoustic engineers or the test engineers, they put a speaker inside this vehicle, and we got a microphone. This you can see here, this thing here, it's a microphone. It's called a 3D microphone. So and we switch on the speaker inside the car, and we capture the sound pressure onto this microphone, and we can place this. It is portable. We can put this microphone on any side of the car so that we can measure the sound transmission loss at different points. And that's about acoustic testing.